Hey everyone, so today we're going to be looking at the outcome, describes how contact and non-contact forces affect on an object's motion. We're going to be doing this through an experiment, and our experiment is going to be focusing on contact forces, specifically friction forces. We're going to be experimenting how the angle of an inclined plane, which is our wooden plank today, when we change it, how it affects the speed of different objects with different surface frictions. The materials that you're going to need today are foil, glad wrap, 5 identical pieces of cardboard, sandpaper, fabric, a long wooden plank, the protractor app, and some scissors. Here are the items we're going to be using today in our clear view for you. And then what you're going to do is you're going to fold those items over those 5 little pieces of cardboard. It's also best to do this experiment with a friend. Here is the piece of wood that I've decided to do the experiment with. I've propped it up on some books to give it that angle. However, you might decide to do this with a piece of cardboard instead. Place the plank at an angle of about 10 degrees to start off the experiment with. This is a good incline to begin with. I measured this angle out using the protractor app on my phone. In this clip here, I'm showing you how we're starting off with the cardboard, the sandpaper, and the foil pieces of cardboard, and how they're all lined up at the same position on the starting board. As you can see, the amount of friction that they have at 10 degrees is not enough for any of these pieces of cardboard with their different surfaces to fall down the plane. Now let's watch and see which one falls first. There goes the foil. Now we need to measure this angle down here to see what incline it fell down the slope at. As you can see in this photo, it went down at about 15 degrees. This clip here is showing how the different contact forces between the two surfaces will depend on what angle they will slide down the surface. And as you can see, the cardboard has a lowered contact force. However, the cardboard did reach a higher angle than the foil did before. Due to the really gritty nature of the sandpaper, it had a very high friction with the wooden board, so it stayed on much longer and ended up reaching to a 29 degrees, which is quite high. This clip here is showing our next two surfaces, which are cling wrap and fabric. These two are very contrasting frictions, as the cling wrap is a very shiny, smooth surface, while the fabric is a very gritty surface. Now it's time to test them and see what angle they go down the board. And of course, as you can tell, the cling wrap went first due to its surface. Surprisingly, it went down at the same angle that the foil did before. This last clip is showing you how the friction of the fabric was so high with the wooden plank that it did not want to fall. It went to almost 90-degree angle until it was able to fall down the plank. This shows how those contact forces are so strong with that friction that it did not want to fall down the plank. As an investigator, what you could do next is repeat this experiment at least 3 more times for reliability, just to ensure your results are accurate. Of course, here is the angle for that board there, which was very high. Now I'm tabling up our results that we saw before, and I've made a very simple table with the surface and then the degree of the angle, and I'm just listing all the different surfaces. Then next to them I'll put down the degree that they fell down the plank on. This gives us a good representation of which ones had the highest degree and which ones was the lowest degree. Using these results, it will show us which surfaces have a higher friction force and which ones have a lower friction force. With these results though, we would obviously have multiple results if we did this test 3 or more times. I'm also showing you the independent and the dependent variables in the experiment. That's just good to know for our results. I'm also highlighting which one had the highest force and the lowest. Now what we're going to do is we're going to be using Scratch Ed to represent our results. So here we are in Scratch, and we're going to be making our own little presentation to show what we learnt during this experiment. So here is my little character, and we're going to be using some simple coding to be able to make our objects slide down that plank. You'll need exactly to code like what we did in object in your screen, and in order to show each of the different objects sliding down the plank, you'll need to code for them. So you have to have a starting code, and then where we want them to move to, what angle we want them to move to, and obviously we want that plank to move in an upwards angle, since that's what we were doing in the experiment. You're then going to have to time things to make sure that they fall down the plank at the correct time. You might also need to use some stoppers so that things don't move when you don't want them to move. So this is all a lot of testing and working out what code works best for your experiment. Make sure you repeat this coding for each of your different objects, and we're going to also do this for each of our surfaces. So the plank will obviously have to move up depending on what surface is falling down. This one here, I have labeled it the foil, and that had our lowest degree of 15.1 degrees. However, you will also be showing the sandpaper, and you might even want to show how the fabric one took a while to fall down that plank there. Thank you so much for watching my experiment. I hope you enjoyed, and I hope you learned something about contact forces today, especially friction forces and how different angles affect our friction forces.